Hello, everyone. Thank you so much for having me here. I am Dr. Joy Alata. So, while I begin, my keynote address is based on Industrial Revolution 4.0, Internet of Things, Sensor Data Interoperability. So, today I will discuss about the technological changes that has taken place in our society, the Internet of Things, the Industrial Internet of Things, Industrial Revolution 4.0, and sensor data interoperability. So there are technological changes around us in the human society. Everywhere we go in today's world, we're connecting. Sensor data and devices are connecting with each other. They're communicating. They're sending data back and forth. And we're trying to understand what the data is and how to use it. Also, there are real-time tracking. You can connect with any object, any asset, anybody in real time in many places. You can know where they are. Logistics are improving. Healthcare is improving as a result of real-time tracking. In the healthcare industry, they have done massive amounts of work. They're trying to save human life in various ways. And these are very, very exciting times. In the industry, things are also changing. In fact, there have been phenomenal changes in the industry as we move from industrial era 1.0 to 2.0 to 3.0 and now at 4.0. There's been so many changes, and there's been use of automation, robotics. The sensors are connecting things. There are the new ways that even items and assets or devices in our homes are connecting and behaving, and they are constantly communicating and sending information out around to us. So that brings us to the Internet of Things. Let me give a basic explanation of Internet of Things, because it doesn't get more complicated than that. Internet of Things refers to a list of or a network of connected devices. And these devices are usually embedded with sensors, with processors, and technological abilities that can enable communication between these devices, within them, outside them, and within their environment, even sending the information to the cloud. These devices are everyday devices, not just in the industry. Gadgets in our homes are talking to each other, in our vehicles, in the streets, around us. Devices and objects are talking to each other. So anywhere you see these are the Internet of Things. They're not far-fetched concepts. So what is powering and enabling the Internet of Things are the sensors. The sensors are the super basic things that are enabling Internet of Things. It is these sensors that are equipped with the ability to communicate, to be able to send messages, to be able to receive messages, and to be able to change the activities or act in different ways based on messages they receive. Then the industrial Internet of Things is a subset of the Internet of Things. The Internet of Things talks about the general everyday devices in different industries, in different scenarios. But the industrial Internet of Things are directed specifically to what is used in the industry. So you can see it's nothing different. It can change, you can change from being an IoT to IIoT. It depends on where it is used. I thought there's need for us to understand the differences. Now, the areas where industrial Internet of Things are being applied and that are making changes to the way things happen in industries, they are used in predictive maintenance. Imagine where you need the machines are sending information, letting you know that this machine will stop at XYZ time, or that there will be need for maintenance, or this an A machine telling you that the B machine is not receiving message or is not communicating properly. They're also using structural monitoring. Think about the bridges, the railways, the roads. Some of these sensors are embedded there and they are used to monitor the structures. Then there are condition-based maintenance. The condition-based maintenance has been widely used, and I think it's one of the most widely used areas because of the need to be able to predict when machines will fail. And you know very well that the ability of machines to work as designed at the appointed time is very key. Think about the smoke alarms you have that can detect that there's so much smoke and then you raise an alarm. Now, in the world of industrial Internet of Things, instead of the alarm just being local, the alarm can be able to communicate with the alert system in the fire department to be for the fire department to know that, hey, there's fire there, or that there's so much smoke. Think about where a noise could alert the police to that there's something going on here. There's an unusual noise in this environment. So it doesn't even require human intervention. So these devices will talk to each other and communicate. And there's need for us to be able to get all the data it's sending out, because this is where the core benefit stays. Now, the Industrial Revolution 4.0, where we have come a long way. We have come very, very, very long way from the days of the steam engines, and today where there are cyber physical systems, today where there are everyday objects talking to each other in the industry, not just very highly sophisticated things. From the simple to the highly sophisticated, think about the robotics, how they're doing in the industries. So the auto industry, the manufacturing, the logistics, all these industries are making efficient and very good use of the Industry 4.0 systems. Now, before I move on, I want to really discuss the difference between the Industrial Internet of Things and the Industrial Revolution 4.0. They're not the same, really, but I know there are many quarters people interchange the use of the two, but they're not exactly the same. There are a few differences, but they're not too far apart from each other. But I think it's important that we look at what makes them different. The Industrial Internet of Things are used mainly on industrial or professional equipment, but the Industry 4.0 primarily focuses on the manufacturing sector. So while the other one, several industries are tapping the use of Industrial Internet of Things, the Industry Revolution 4.0 are at this point mainly being used for the manufacturing sector. And then, look at again the concentration, the value chain for the Industry 4.0 is on digitalization of the chain, but on the Industrial Internet of Things, there's more emphasis on security, on data security, on system security, on the device security, and there's a whole lot of information and communication technology content on the Industrial Internet of Things. And lastly, the Industrial Internet of Things is purely driven from the private sector perspective, but the Industrial Revolution 4.0 is driven from the government sector. So even where we see them being used interchangeably, let's try to understand that there are a few differences. Then the drivers of this Industrial Revolution 4.0, these are the things that are really pushing the use. These are the things that are bringing it. And as we know, the Industrial Revolution 4.0 is still evolving. Has not fully evolved. Though there's now been discussions about Industrial Revolution 5.0, the Industrial Revolution 4.0 has not fully evolved. Now, you think about the machine-to-machine communication. the facilities, the cities, the smart cities. These are part of the Industrial Revolution 4.0. And you all know very well that so many cities are not yet smart. Even the so-called smart ones, there are still very few. And the core benefits or the potential benefits are yet to be harnessed. This is why it's important that we pay attention to the manufacturing of those devices, the sensors that, and even the technologies that help to support the communication. The monitoring devices that we see every day, the ones we use in sports, and used to monitoring our blood pressure, our heart rate. Then also you see all of them, the ones also we use in the energy industry. All these monitoring devices, they are the drivers, they are the ones pushing the Industry Revolution 4.0. The healthcare industry, I keep saying, emphasizing, have done so much with Industrial Revolution 4.0, and they're still getting on with it. So that's why I keep saying it has not fully evolved. There's a lot that still needs to be done. And the potential benefits that we get from those data that the devices are sending out from left, right, and center have not really been harnessed. So many organizations are still dealing with how to store those data because they are now classified as big data. So these benefits, the improved productivity, increased efficiency, higher outputs, improved customer service, they are there. But the truth is that they still haven't been fully harnessed. And why are they not fully harnessed? Why are these benefits not automatic? It's because of sensor data interoperability. Because before we can start using making intelligent decisions, before we can start fully utilizing all the communication, all the data that is being spun out from the devices, the data must be compatible. The systems must feel comfortable with each other. That means the issue about cybersecurity, about vulnerability, about privacy must be taken into consideration while manufacturing these devices. These devices, it cannot be business as usual. In the past, when these devices are not connected to each other, different manufacturers do their things the way they want it. But now there's need for use of standard protocols, standard processes, standard workflow, standard data interchange, and connectivity. So these are the issues that will have to be taken care of for the data to be able to make sense, for us to harness it and convert it to information. At this point, there's so much data flying around, but it hasn't, the ability to convert it to information is still something that organizations are struggling with. Now, one of the other issues about sensor data interoperability is on the different types of sensors. There are so many. There are so many. There are so many manufacturers, all different, using different concepts. There's need for convergence of processes, of protocols, of communication systems and communication style. And then of the data format. The data format is so important because if machine A or if sensor A is saying something to sensor B, they are communicating, but they're sending messages really, but they're not really communicating because the machine B cannot be able to make a decision based on what machine A is saying because they don't understand what each other is saying. You might as well be speaking different languages. And that is a big problem. For us to be able to harness all this data that is lying around and converge it to make it to become information that we can use for our intelligence systems and for making improved decisions, we need to have some standards. And these are some of the issues that are still being worked upon. There's been a lot of improvement, the truth is there's still a lot that needs to be done. Then some of the other challenges, as I've mentioned earlier, standardization is so key. There must be same standards for the devices, for the processes, for their communication. Then the issue about safety and reliability must be taken into consideration by different manufacturers. Then there's a security. We know anything that is available through the internet is subject to cyber attacks. So how do you ensure that the data that is being spun out is actually coming from your device? This is where cyber security is important. So device manufacturers must be able to take that into consideration as they sending out the data and as new types of data come into play. So in summary, the interplay of industrial IoT, the IoT and Industrial Revolution 4.0 must be logically and systematically applied, designed, processed for it to begin to make sense. And there's need for IoT, which is in Internet of Things architecture and technology, to be designed for efficient and effective use. Convergence is a key word I'm leaving out here. Convergence must be in place for the benefits, all the huge benefits we've seen, and the potential benefits we will get from the industrial Internet of Things and from the Industrial Revolution 4.0 must be hinged on the ability to standardize everything, every devices that are connected to each other and are communicating with each other. Thank you so much for your time. I can take some questions now. Okay, so thank you. Thank you for having me.